So now we will be solving the simple repetition problem of Div3 problem statement number 3. So Pasha loves a prime number. Once again, in his attempts to find a new way to generate prime numbers, he became interested in an algorithm found on the internet. To obtain a new number y, repeat k times the decimal representation of number x. For example, let's say x was 52 and k is 3. So the number which will be generated is 52, 52 and a 52. So 3 times 52, right? And if it's x is 6 and k equal to 7, then 7 times we get a 6. Right? So Pasha wants to know the resulting number is prime or not, and we need to find the value. So I guess the problem statement is key. Let's say 52 is written 3 times, right? So it becomes 52, 52, 52, and we need to find that it is a prime number or not. So this problem is little bit on the easier side, because if you think, see, if you write 52 more than once, right? Let's say 52, 52, right? So 52, 52 is itself divided by 52, right? Let me show it to you. I don't know if it's work. Look, hold a second. So let's say I have been given a number 52. So 52, 52. If you divide it by 52, right? So it's easily divisible, right? 1 is 0, 1. So any given number, let's say I was given 43, right? 43 is a prime number, right? So if you write 43 2 times also, no? Yeah, 3 times, yeah, 4 times, any number of times, let's say I have written 3 times. So 43 divided by 43 itself, right? It will be divisible, right? Let's say 1, 0, 1, 0, 1, right? So here what we can observe is if we generate any number, right, k times, right? So it is divisible by itself, right? So this is the first observation which I guess we could use, right? So what does this mean? If k is greater than 1, right, then number is not prime, right? Okay, but there is a edge case, right? A small edge case, right? What is that? It is for n equal to 1. Why? See, if you take k equal to 2 for 1, it becomes 11, right? And 11 is a prime number, right? So this was the thing which just the only edge case in this problem. Other rest of it, if you give any number of times, it is already a not prime, as I said. So this is the condition, and if n equal to 1 and if k is equal to 2, then just it's an edge case. You need to just figure it out that yeah, it's a prime number, and you are all set to go, right? Now I guess we don't need to spend that much time on this problem. If it's clear, let's see the code right now. So here is the code. What I'm doing is I'm taking n and k as input, and the edge case I'm already, first of all I'm checking the edge case, right? So if what is the edge case? Edge case is if n equal to 1 and if k equal to 2, then see out a yes that yeah, it's a prime number. Else for any one it will not be divisible, right? So let's say if k was 3, so it becomes 1 then 1, and it is divisible by 3, right? Or 1 1 1 1 4 times, it is divisible by 11. Again 1 1 1 1 1, it is divisible by any given number. It will be divisible, that's for sure, right? So any given number, if it's not greater than 2 for n equal to 1, then it will be divisible, right? And rest I said, if k is greater than 1, then it's never a prime number. And if k is equal to 1, then we have to check that if it's prime or not. And I have written a function for it. If is prime, then if it's a prime, then see out yes or no. Now what's the logic for is prime? So we are traversing from 2 to less than sqrt of n, right? Just to save a little bit of time, right? And if n mod I equal to 0, then no, it's not a prime number, return a false, else return a true. So I guess test cases are code is clear. I guess test case is the last one is test case. So never mind, it will work. I will put the code in the description as well. do check it out, and if you like, please subscribe.